Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cyber Security, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss the topic data transfer, manipulation, and program control instructions. So, already we know what is instruction. Instruction is a command to the processor in order to perform certain operation. So that is called instruction. So based on the type of operation they perform, the instructions are classified into different types. So mainly the instructions are classified into three types, that are data transfer instructions, data manipulation instructions, and program control instructions. So these are the three main classification of the instructions. So data transfer, data manipulation, and program control instructions. So let's see one by one. So let's start with the data transfer instructions. So the data transfer instructions move data from one place to the another place inside the computer. So without changing the data content. So using this data transfer instructions, we can copy the data from one place to the another place within the computer. So without modifying. So that means suppose if you have a instruction move a comma b. So here in move a comma b, we are transferring or we are copying the data from register B to the register A. So here we are not modifying the contents of the register, just we are copying the data from one place to the another place. So that are called data transfer instructions. So these data transfer instructions, they can also call copy instructions, because we are copying the data from one register to the another register. So that's why these are called copy instructions. And using this data transfer instructions, mainly we can copy the data from one place to the another place within the computer. So from where to where we can copy the data. So from the memory and processor register. So using this data transfer instructions, we can copy the data from memory and processor register. So between the memory and processor registers, we can copy the data. Similarly, between the processor registers and input output devices. So in between the processor register and the IO devices, using this data transfer instructions, we can copy the data. And the last one is the processor registers themselves. So that means register to register transfer. So this is an example. Okay, so that means here the contents of one register we are copying to the another register. So that means we are copying the data in between the registers. Okay, so these are the different places between them we can transfer the data using this data transfer instructions. So first one is between memory and processor registers, and the second one is between the registers and the IO devices, and the third one is between the registers themselves. So these are the three main most common transfers are between. And let's see the examples of the data transfer instructions. So here we have specified a name and their mnemonic symbols. So the first one is a load. So load instruction, it is represented with a capital LD. So LD means load. Next, store, it is represented with ST. Move, it is represented with MOV. Move. Exchange, XCH. Input, in. Output, OUT, out. Push, PUSH. Pop, POP, pop. So these are all the different data transfer instructions. So let's see their use. So first one is a load instruction. So using this using this load data transfer instruction, we can transfer the data from memory to a processor register. So usually an accumulator. So usually the register is the accumulator. So that means loading. So we have a memory. We have a memory, and the memory, it contains different memory locations, and each location we can store some data. So let us assume some 0, 5, 23, 46, 58, something like that. Okay, so here load. So what is the use of this load instruction? It will copy a data from the memory location, Okay, suppose here 46 is there in the 4002 location. So we have a register accumulator. So using this load instruction, it copies the data from a memory location to the register accumulator. So after copying, so this 46 is copied into the accumulator register. So that means here the source data will not change. Just we are copying the data from one place to the another place. That means the load can be used to copy the data from one memory word to the register. So that is the first one. Second one, store. Store is the opposite operation to the load. So in load instruction, we have copied the data from memory to the register, but here it is opposite. That means from the register to the memory. So using the store, it transfers from processor register into memory. So this is called memory write. So we are inserting a new data into the memory. So that is nothing but memory write. Similarly, memory read. So load is nothing but load instruction is nothing but it is a memory read operation. Memory read. So memory read is nothing but we are taking we are retrieving the data from the memory, and that we are going to load into the register. So that is a load instruction. So these are the load and store instructions. So these two instructions are opposite in operation. And move instruction. So move, already we know move is an instruction. Using this, we can copy the data from one place to the another place. So that is called move. So already we have also seen from where to where we can copy the data. So next one is a exchange. So this exchange, using this exchange instruction, we can swap the information between the registers. We can between the two registers or a register and a memory word. And next one, input or output. So the transfer data among processor registers and input or output device. So using this input output instruction, either we can transfer the data from input to device to the register, input register to input to device. We can input register. We can copy the data from input to device to registers, or register to output device, or register to output device. So this is using the in instruction, and this is using the out instruction. So this in and out especially we are using when we are dealing with the input or output devices. And the last one is a push or pop. So this push or pop, it transfers the data between processor registers and a memory stack. So between the registers and memory stack, this push and pop instructions are used to transfer the data. So these are the different data transfer instructions. And coming to the second type of classification, that is data manipulation instructions. So data manipulation instructions perform operations on data and provide computational capabilities for the computer. So this data manipulation instructions, it performs operations on some data stored in the registers. Okay, so using this manipulation instruction, using this data manipulation instruction, so we can modify the contents of the register. Okay, so these data manipulation instructions are mainly classified into three types. The first one is the arithmetic instructions, second one logical and bit manipulation instructions, and third one shift instructions. So these are the main classification of the data manipulation instructions. First one is a arithmetic. So arithmetic instructions. So here the main four basic arithmetic operations are addition, subtraction, multiplication, and division. So these are the main classification of the main arithmetic operations. Okay, so let's see the different arithmetic instructions. So the first one is increment. So here the entire all the arithmetic instructions we have given in a tabular column. So first column is the name, second one is a mnemonic, third one example, and fourth one is a description about that particular instruction. So first instruction is a increment. So the mnemonic is a INC. So that means the instruction is represented with INC. Example INC B. So that means we are performing increment operation on the data which is stored in the B register. Okay. So what operation will perform by executing this increment instruction? So it will increment the register B value by 1. So suppose if you have a register, let's see, let assume some 4-bit register is there. So in that you have a data 010. So what is its decimal value? Its decimal value is the 5. It's a decimal value 5. So if you increment the value, which is stored in this B register, so what will happen? So 5 plus 1. So incremented means only one value will be incremented. So 5 plus 1. So that is equal to 6. So after executing this increment B instruction, its value will be replaced with 0, 1, 1, 0. 0, 1, 1, 0. So using this 8, 4, 2, 1. Okay. So that means previously the register it has 5, but now it is incremented to 6. So using this increment operator, the value of a register will be incremented by 1. And coming to the second one, decrement. Similarly, using this decrement instruction, its value will be decremented by 1. So that means suppose if the register is having some 7, 0, 1, 1, 1. So that is equal to, what is the value? So 7. So its decimal value is 7. So if you perform a decrement operation, its value will be decremented by 1. So that it will be decremented to 6. So 6 means, see here, 6. So 0, 1, 1, 0. So that means its value will be decremented from 7 to 6. So that is a decrement operation. And coming to the add means addition operation. So mnemonic is add. And example add B. So it will add contents of register B to the contents of the accumulator. So here the contents of the B register we are adding with the contents of the accumulator. So accumulator content it is added with B register, and finally the result will be stored in the accumulator itself. So that is called addition, add. And next one, subtraction. So this instruction it will perform subtraction operation. So mnemonic is the SUB. Example SUB B. So here we are subtracting the contents of the B register from the accumulator. After that, result will be stored in the accumulator. Next, multiply. So it performs the multiplication operation. So it multiplies the value of the contents of the B register multiplied with the accumulator register. Finally, the result will be stored in the accumulator. So the mnemonic is the mul. Next division, div. Okay, so this div, it performs the division operation. So the contents of the B register, it divides the contents of the accumulator, and result will be stored in the accumulator. So accumulator is a default register to store any result. Next, add with carry. So add with carry means we are adding two registers along with the carry. So here accumulator register, B register, and the carry flag will be added, and result automatically will be stored in the accumulator. So the mnemonic here for the add with carry is the ADDC. The initial example ADDC B. Next, subtract with borrow. So the mnemonic is a SUBB. Example SUBB B. Okay. So here subtract with borrow. So that means we are subtracting the B register content and the carry flag content from the accumulator, and the final result will be stored in the accumulator. Next, negate. So negate, it performs the 2's complement operation. 2's complement. So it is a represent negate. It is represented with the mnemonic neg, negate. Example neg b. So it performs 2's complement operation on the data stored in the B register. So it performs 2's complement. So how we can perform the 2's complement? In order to perform the 2's complement, first we need to perform 1's complement, then we have to add 1, so that you will get the 2's complement value. So here B bar. So what is B bar? B bar is a 1's complement. Next we are adding 1. So 1's complement plus 1. So finally the 2's complement value will be there. That 2's complement value will be stored in the B register. Okay. So these are the different arithmetic instructions. And coming to the logical and bit manipulation instructions. So these logical instructions perform binary operations on the strings of bits stored in the registers. So they are useful for manipulating individual bits or group of bits that represents binary coded information. So this logical and bit manipulation instructions either we can perform on a single individual bits or a group of bits also. So examples are clear. The mnemonic is CLR. Example clear. So when you give a CLR instruction, it will clear the accumulator register. So clearing is nothing but loading zeros into the register. So loading zeros into the register accumulator. Next, complement. So mnemonic is a COM. COMA. So that means this instruction, it performs complement operation. That means inverse operation. Suppose if the register having, so you have a register accumulator that takes 4-bit register. Okay, 4-bit register. So you have a 0, 1, 0, 1. So this is a accumulator. So if you perform a complement operation, its content will be complemented. That means 0 becomes 1, 1 becomes 0. So that is a complement operation. So 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0. So this is a data after complementing operation. Next, AND operation. AND. So we are performing a logical AND operation between the registers. So between the registers, accumulator and the B register. So here we are using two registers. One is a accumulator and another one is a B register. So in between them we are performing a AND operation. So what is AND operation? Okay, so see here. In order to perform AND operation, we require two bits, two input combinations. Let us assume A and B are the two input combinations. So if the inputs are 2, that means 2 power 2 combinations are there. So 2 power 2. So 0, 0, 0, 1, 1, 0, 1, 1. So these are the different input combinations. So in AND operation, let us assume Y is the output of the AND operation. So if any one of the input is logic 0, then output is 0. The output is logic 1 only if the all inputs are logic 1. So this is a AND operation. Next, OR operation. So what is OR operation? OR operation is it performs a logical OR operation. Okay. So OR operation. So here OR operation. So what is OR operation? So if any input is logic high, then output is logic high. So output 1, 1, 1, 0. So that is a OR operation. So this OR operation we are performing between the accumulator and the B register. Next, exclusive OR. So XOR. So it is represented with XOR mnemonic. XOR B. So we are performing XOR operation. So what is XOR operation? Let us assume A and B are the inputs of the XOR gate. Then Y is the output. So what are the input combinations? 0, 0, 0, 1, 1, 0, 1, 1. So these are the input combinations. So in XOR gate, the output will be 1 if the inputs are different. So in the second and the third case, the inputs are different. So that here you will get logic 1 as the output. And logic output is a logic 0 if the input bits are same. So this is a XOR. This is a XOR operation. Next, clear carry. So clear carry, that means this clear carry, it is used to perform on a single bit. So that is nothing but carry flag. Carry flag. So carry flag is nothing but it is a single bit. So on that we are performing this clear carry. Clear means we are clearing the carry flag. That means a 0 will be loaded into the carry flag. So for that mnemonic is the CLRC. CLRC. That means clear carry. Next, set carry. Set carry means we are loading 1 into the carry flag. Mnemonic set C. Next, complement carry. Complement. The mnemonic is a COMC. Complement. Complement means already we know. So 0 will become 1. 1 becomes 0. Next, enable interrupt. So mnemonic is a EI. So it will enable the interrupt. So see here whether the processor should allow the interrupts or not. That depends upon this enable interrupt. If EI is equal to 1, that means the interrupts are enabled. Suppose if you want to disable the interrupts, then this DI should be 1. Okay, so DI is equal to 1. So disable interrupt. So if DI is equal to 1, then the interrupts will be disabled. So the mnemonic is DI. This DI is used to disable the interrupts. So once you disable the interrupt, so no interrupts will occur. And coming to the third category of the data manipulation instruction, that is nothing but a shift instruction. So the instructions to shift the contents of an operand. Okay, so that is called shift instructions. So using this shift instructions, we can move the data either to the left side of the register or to the right side of the register. So you can see here we have a register here. So let's take a 8-bit register. Okay, so this is a 8-bit register. So in this we have a data. So this is a data presenting. So this data either we can move left side, or we can shift to the left side, or either we can shift to the right side. So either operation we can perform. So these are called shift instructions. So let's see what are the different shift instructions are available. So first one is a logical shift right. Logical shift right. So this is a shift right. So the mnemonic is SHR. That means we are performing a shift right operation. So we are performing shift right operation on the data stored in register. Okay. So see here. So shift right. That means suppose if you perform one shift right operation, what will happen? So this is D0, D1, D2, D3, D4, D5, D6, D7. So these are the bit positions. So when you perform one bit shift right operation, so this D0 position data will move out of the register. And next, this D1 bit position data will be shifted to the D0 position. Next, D2 position will comes to D1. So like that, all the data, it will be shifted to the right side by one position. So when you shift the data to the right hand side, then this D7 position is empty. It is vacant. So that vacant position, it is filled with zeros. So that is a shift right. Similarly, next one is a logical shift left. Logical shift left. So the operation is the same, but here we are performing a logical shift left instead of shift right. So shift left. So that means we are shifting the data towards the left side of the register. So that is a logical shift left. And next, arithmetic shift right. Arithmetic shift right. So arithmetic shift right is arithmetic shift right. So see here, arithmetic shift right. So this arithmetic shift right is the mnemonic is SHRA, shift right, arithmetic shift right. So here it can be used as a sign preserved. That means here the D7 position sign will be preserved. Especially this arithmetic shift right and arithmetic shift left, it is used for signed numbers. So we are performing this arithmetic shift left and shift right operations on the signed numbers. Okay, so that's why the sign of this number will be preserved. So 0 means it is a positive number and 1 represents a negative number in signed numbers. Okay, so always this D7 position will be preserved and it will be copied to the right side. It will be copied to the right side during shift right arithmetic. And shift left, arithmetic shift left. So this arithmetic shift left, it is similar to the logical shift left. So same operation. But using this arithmetic shift left, it can be useful for signed number, and this logical shift left, it is used for unsigned numbers. That is only different. Remaining operation is same. And next to rotate right. So here you have a register. So the register, it contains the data like this. So rotate right. So here. So in rotate instructions, we will not lose any data. So whatever the data present in the register, that will be rotated in a circular fashion. Either it is from left to right or from right to left. So here rotate right. So that means the data is moving in this direction. Rotate right. Okay. Similarly, rotate left. So rotate left means here the data is moving in this direction. Suppose if you perform one rotate left operation, so this 0, so this is D7 position, this is D0 position. So the D7 position data, when you perform shift left operation, this D7 position data will comes to D0 position. Okay. Next, so this D6 position data will comes to the D7 position. So 1, 1, 0, 1, 1, 1, 0. So that means here. So in this way, the data will be shifted. The data will be rotated to the left. Rotate left. So this is a rotate left. So it is represented with ROL. Rotate left. For rotate right, the data will be moving in this direction. Next, rotate right through carry. Rotate right through carry. So see here, rotate right. So you have a register and you have a carry. So this is carry flag and it is a register, 8-bit register. So that means here, this is carry flag. This is carry. So that means rotating. We are rotating the contents of the register through the carry flag. So that's why it is called rotate right through carry. And the mnemonic is RORC. So suppose if you have a data 0 0 1 1 1 0 1 0 and let us assume the carry flag is 0. So when you perform rotate right through carry, so what will happen? So this 0 rotate right. So this 0, whatever the 0 is there in the carry flag, that will be loaded into the this D7 position. So 0. So this D7 position 0, it will be copied to here. So this will be copied to here. This is copied to here. Here. So here 0 1. So this 0 will be loaded into here. So this green color is the contents of the register after performing the rotate right through carry. So this is red. The number represented with red color is the contents before performing the rotate right through carry. Okay. Next one is rotate left through carry. So instead of rotating right, we are rotating the data to the left side. So the carry flag will be in this side when we are performing rotate left. Okay. So this is a rotate right through carry and rotate left through carry. So these are the different shift instructions. So in data manipulation, so till now we have seen the arithmetic operations and logical and bit manipulation instructions, and also we have seen the shift instructions. So then we are moving to the third category, that is program control instructions. So these program control instructions specify the conditions for altering the contents of the program counter, while the data transfer and manipulation instructions, it specifies the conditions for data processing operations. So using this program control instructions, we can alter the contents of the program counter. So let's see what are the different program control instructions. So branch, jump, skip, call, return, compare, test. So these are all the different program control instructions. Branch. So branch. So these are all this branch, jump and skip. So these three are conditional or unconditional. So it may be a conditional branching or it may be a unconditional branching. So what is branching? Branching means transferring the program control from one location to the another location. So that is called branching. And jumping also, that means we are jumping to the address which is specified in the address field of the instruction. Suppose if you write jump 3000, so that means when the program is executing, whenever this instruction is executed, then the program control will be transferred from this address to the 3000 address. Let's see. You can understand this with an example. So consider a memory with the different memory locations, and the address is 2000, 2001, 2002, 2003. So these are all the different memory locations. So because when you are performing any operation with the memory, that means either you are performing memory read or memory write, that we can do with the help of the address only, memory address. So without memory address, we cannot do anything with the memory. Okay, so these are the memory addresses. So let us assume in a 2000 location, we have a jump. We have a jump instruction. So let me write with red. Okay, so this is jump. So jump 2005. Okay, so in 2000 location we have a instruction jump 2005. So actually, when the program is executing, first it starts with the first instruction 2000. After executing, the program control will be shifted to the next instruction 2001. So, but here instead of going to the next address, that is nothing but 2001, the program control is shifted to the 2005. So that is called jump or branch. And skip. So this skip instruction, it can be used to skip the instruction. That means whenever this instruction is executed, that particular memory location will be, or that particular instruction will be skipped off. Next, call, and it is represented with the mnemonic CALL, call. So this call and return, RET, these two especially we are using when we are dealing with the subroutines. So what is subroutine? Subroutine is a function. Subroutine is a function. Whenever we call any function, then the program control will be transferred to the function definition, and all the statements in that function definition will be gets executed, and using the return address, it will be written back to the main program where it left the main program. So that is a call and a return. Okay, so let's see. So that you can understand with example. So we have a memory. So here we are discussing about the call. So in 2000 location we have a call 3500. So whenever this call instruction is executed, the program control will be shifted from 2000 location to the a new location. So new location means 3500. 3500 means see here. Let us assume here 3500, 3501, 3502. So like that. That means the program control will be transferred. The program control will be transferred from the 2300 location to the this 3500. So because this address is specified in the address part of the instruction, so that's why directly it will be transferred to the here, because here in the 3500 location there is a subroutine. Subroutine means a sequence of a set of instructions that are to be executed frequently. So that we are storing somewhere in the memory, and we are calling from the main program whenever it is required. So that is called subroutine. So whenever the subroutine is called, then it will go to the subroutine, and all the statements in that subroutine gets executed. And in the subroutine, the last instruction will be RET. So return. RET means return. So whenever this return instruction is executed, the program control will be transferred from the subroutine to the instruction, the next address, the address of the next instruction of the main program. So this is a main program. So what is the next address? 2001. So the program control will be transferred to the this location. So that are call and return. And next one, compare. So compare. Suppose you compare CMP. The mnemonic is CMP. CMP A comma B. So that means here we are comparing the contents of the B register with the A register. So B register content we are comparing with the accumulator A register. Okay, but here only this comparison instruction, it just compares the operands. The result will not store anywhere. So comparison is nothing but it is a subtraction. It performs A minus B, but the result will not store anywhere in the register. Only the comparison instruction, it will update the flags. It will update the flags. So what are the different flags are there? We have different flags: carry flag, sign flag, parity flag, overflow flag, auxiliary carry flag. So like that, different flags are there. So based on the result, any of these flags will be set or reset. Only just this comparison instruction, it can be used to update the flags only. The result will not store anywhere. And test. So this test instruction is nothing but performing the AND operation. So like test A B, test A comma B. So that means here we are performing AND operation between the contents of these two registers. So this compare and test used to set conditions for branching instructions by updating status bits. So compare and test instruction do not retain the results of the operation. They only set or clear the certain flags. So in this lecture, we have seen different instructions. So mainly the instructions are classified into three types. Okay, so data transfer, data manipulation, and program control instructions. So all these we have discussed in detail with examples also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.